Modeling the ML Lifecycle Part 3. Part 1 got the ingredients. Part 2 washed and chopped them. This right here, this is cooking the dish. If you've been following our explainer series through Parts 1 and 2, you know our data is finally prepped and ready. Now we step into the third phase of our pipeline to see how that data actually gets put to work. We are crossing over from just preparing information to actively generating intelligence. Section 1, what it actually is. Modeling is the stage most people picture when they hear the phrase machine learning. It carries all the glamour, right? But remember, it is just one part of a much bigger process, and honestly, it's completely useless without the first two stages pulling their weight. Here, our clean, model-ready data flows straight into the algorithm. Now, the model doesn't just memorize this information row by row. Instead, it systematically uncovers hidden relationships and complex patterns buried within the data. That is the true magic of machine learning, gaining the ability to mathematically understand those relationships so well that the model can make highly accurate predictions on entirely new, unseen data. This is exactly why our prep work was so vital. The foundational concept here is literally garbage in, garbage out. If you skip pre-processing or fail to acquire good data in the first place, your models simply won't learn, regardless of how advanced your modeling technique might be. A powerful algorithm fed terrible data is completely ineffective. You see, the ceiling for your model's intelligence is forever set by the quality of your data.
So how does this learning process work under the hood? Let's break down the core mechanics of the modeling stage.
Section 2, the main steps. There are 4 essential steps that make up the bulk of modeling work. Let's explore them in order. Step 1 is choosing an algorithm. This means picking the specific type of model best suited to your problem. Different algorithms make different fundamental trade-offs. Some prioritize rapid processing and simple explainability, while others prioritize untangling massive complexity at a heavier computational cost. The right choice depends entirely on the structure of your data and what you are trying to accomplish. Step 2 is training. This is where the model actively learns from the data. You can think of it as an intensive cycle of trial and error. By repeatedly adjusting its internal parameters to reduce its error rate, the model gets incrementally better, sharper, and more precise at its assigned task with every single pass through the dataset. Step 3 is hyperparameter tuning. Think of these as the master dials and switches that control how the model learns. Unlike internal parameters, these are not learned automatically during the training phase. You have to set them beforehand. You are adjusting external constraints like learning speed. Getting these settings just right can dramatically shift your model's final performance. Step 4 is evaluation. This ties directly back to our previous metrics explainers. If you're predicting a number, you look at MAE or RMSE. If you're predicting a category, you rely on precision, recall, and F1 scores. And remember, ROC-AUC is your go-to for seeing how well a model separates categories across all possible thresholds, giving you the complete picture. When you look at these 4 steps laid out together, the crucial takeaway is this. Evaluation is the only step that proves whether the first 3 steps did their job. It is your reality check. Think about a chef serving a complex dish without ever taking a moment to taste it. A model that merely looks like it is working and a model that is mathematically proven to work are 2 entirely different things. Skip evaluation or use the wrong metric for your problem, and you risk shipping a broken product that quietly fails behind the scenes. Knowing your model is sound is what prepares us for the final stage, deployment. But before we cross that finish line, let's recap our journey so far. In the modeling stage, the algorithm learns from prepared data by choosing a model type, training it, tuning its settings, and evaluating it rigorously. It is the superstar stage of machine learning, but it entirely depends on the unsung heroes of data acquisition and pre-processing to even get started. That concludes Part 3 of our ML Lifecycle Explainer. Comment Lifecycle if you want us to dive into Part 4, Deployment, next. If you're working on your own AI project and want an expert hand, reach out to us at info@aitechhub.ca. We have our model perfectly trained and evaluated, but a brilliant model living in a vacuum on a laptop helps absolutely no one. How do you take this complex code and safely unleash it into the real world without breaking everything? Subscribe to find out, and we'll see you in Part 4.